Okay, so we've got pre-calc P4, day 2, continued today. The objective, students will be able to use concepts of slope and y-intercepted graph and write linear equations in two variables. So we have parallel and perpendicular lines. So two non-vertical lines are going to be parallel in parallel sign, if and only if their slopes are the same. And two non-vertical lines are perpendicular, that's the sign for perpendicular, if and only if their slopes m1 and m2 are opposite reciprocals. That is, if and only if m1 is equal to the opposite of m2 inverse. Or we could say it this way: if I take m1 and multiply it by m2, their product is -1. So now, with that in mind, find the equation of line through point P 1, -2, that is parallel to line L with equation 3x minus 2y equal 1. Well, I've got to get my slope. Okay, I'm going to use this formula, my point slope formula, where I just need a point, x and y, and my slope, and able to write the equation. So now I'm going to take and subtract 3x from both sides here. So I get -2y equals -3x plus 1. Now I'm going to divide by -2 and I get y equals 3/2 x minus 1/2. My slope is 3/2. So now I plug in my point, 1, -2, and my slope, 3/2, into this equation, the point slope form. Now this is good enough for an equation in point slope form. It's great. But if I were to enter it in my calculator, or I was asked to put it in slope intercept form, this being point slope, I have to subtract 2 and distribute and then subtract 2 from both sides. So I can get this when I am working on distributive property, and because it's 3/2, my 2 is 4/2 here. So that's still 2. It's, it's gone through a procedure, so it's the same value, it just looks different. Okay, and now I subtract 4/2 from both sides, and I'm able to come up with y equals 3/2 x minus 7/2. Now, your turn. You guys get B done doing the same thing using that equation. Just turn it off and then try it and then turn it back on. Okay, welcome back. Hopefully everything went well. Now, keep in mind on this one, the setup is really kind of nice because I have a point and the slope is right here, -4. So I can just pop everything in point slope form. And again, to put it in slope intercept form, I got to distribute that -4 across, and I get y plus 3 equals -4x plus 8. Now I'm going to subtract 3, and my final answer is y equal -4x plus 5. Now keep in mind benefits of solving. If I'm going to put it in my calculator to see what the graph looks like, I'd have to have y equals everything, so I have to be able to do that. But more importantly, I've got point slope form to start with, and if I take point slope form and solve for y, I get my slope intercept form. Now, that was parallel lines. Let's talk about perpendicular, and you'll notice that the questions are very, very similar as we're stepping through these. Okay, so the first one is y minus y1 equals m x minus x1. Well, we're going to step through and solve for our slope. But our slope is 3/2, and it would be 3/2 if we were going to use it for parallel. But because it's perpendicular, it's opposite reciprocals. Take the opposite and flip that slope. So now using point slope form with the same point 1, -2, I now have my equation of the line perpendicular to the line provided through this point. Solving for y, distribute, and then subtract 2, I get my slope intercept form version of the equation. Again, I can put that in my calculator. Now it's your turn to try B using the same equation and method for a point, equation through point 2, -3 perpendicular to y equal -4x plus 3. Go ahead, turn off the recorder and make your attempt. Now, welcome back. Here's the deal. You should be able to quite quickly find that your slope is 1/4 and know that you're going to plug it in 1/4 here. You got your 2 in for x, your -3 in for y, and now you got your point slope form. After that, you distribute and solve for y, and you're golden with slope intercept form. So hopefully those methods are a reminder from Algebra 2, geometry, and even linear algebra. Those are the things you went through during those years in classes. So let's go on here. Applying linear equations in two variables. Linear equations and their graphs occur frequently in applications. Algebraic solutions to these application problems often require finding an equation of a line and solving a linear equation in one variable. Grapher techniques complement algebraic ones. So as we're looking through this, we're going to do what we just did, but we'll look at it on a graph and see what that looks like too. And I've got pictures, screen capture shots of my graph to see what's going on. Find the depreciation of real estate. Camelot Apartments purchased a $50,000 building and depreciates at $2,000 per year over a 25-year period. Now, you're going to write a linear equation given the value y of the building in terms of the years x after purchase. So what I'm looking at is I've got a constant rate of change. This is a linear relationship because I'm depreciating 2,000 per year, and this per part is where my depreciation comes in. Now, keep in mind, that's my constant rate of change. My initial value, 50,000, is here. So as we're stepping through, we have this for our equation. Okay. Now, I can put this stuff into my calculator, and just to see what that graph will look like, it comes down here. It starts out at 50,000 and depreciates 2,000 per year as I go down. Now, how many years will the building be 24,500? There's a couple ways for me to do that. I can hit trace on my graph and I can arrow down, and my trace can change every 0.25 of a year as I go down, or I could do it graphically. So, I mean, algebraically, not graphically. This is my graphic answer. Keep in mind, I want to know when it's 24,500. Well, this is my original, and this is my cost at the end equation, giving the value y of the building, my y value, my costing or y value. So 24.5 goes here. And now I just solve for x. And I find it's 12.275. And I have to, know what that means. And it's 12 3/4 of a year. That's when my building would be worth 24,500. After 12 3/4 of a year. Now, I can use my calculator, and if I pull up my calculator here, and I'll pull this up on the side, and I'm going to put some stuff in here. Right now I've got that, and I'm going to deselect some things. So if I've got other things selected, I just bounce on where they're selected and hit enter and deselect them. We're going to put this equation into the calculator, and we have negative 2,000 x plus 50,000. Okay, now I can graph that, but I want to make sure I have a fit. So I can quickly zoom fit my graph. So I'm going to go with zoom fit. So I'm going to go down one more. I think that's at 10 on this one. I want to show you where that's located. I couldn't dink around with my window, but I'm just going to go zoom fit at 0. And then hit graph. So here's that graph that I was talking about that looks very much like this one. And if I hit trace, I can arrow across and I can find out what's going on with my graph as I'm going down. Okay, and as we go down, those are negatives. I've got to get back to the other quadrant here for whatever reason. Well, my zoom fit, let's check out my window. My x min is 2,000. So my x min, remember my x is going across here, and that should be 23.5. Let's go 23.5. And then that's my max for my x. Let's go back, make that a 0. Let's delete these. And let's go x max as 25. And let's go my y as 0 to 60,000. 0 to 60,000. Sometimes that fit doesn't work well, but now I've messed around with my window, and I want my step to be at 0.25. That'll help every quarter of a year. Okay, so I'm going to hit graph. So we got that nailed. Now I can look at my trace. Okay, and I can go back, and it should increment as I go. We're going to bring it back, and there we are. And now I'm looking at this, my trace-wise. Now we got 13, 12.5, 12. Boy, it's not exact, but if I want, I can bring up my table, and my table's here, right here it's table. So I can go second table, okay? And I want my table to go in 3/4. So I can go in for my delta, and my table set is right here. So second table set, and my table started at 0. Well, at 4, I want to start it at 0, but I don't want to go up by ones. I want to go up by 0.25, okay, because I kind of know what it is, but I'm going to look at it what it is graphically. So I'm going to hit the graph again, or excuse me, hit my table again, and now it goes up by 0.25, and I can arrow through and watch the expense or cost of the building, the value I should say, building value drop throughout time as I go through. And I can actually just find, cursor through and find my solution here at 12 3/4. If it stops, because I got click happy. Okay, we're going to be bringing that back. And we got 12 3/4. So at 12 3/4, it's 25,500. So I've shown you the table set. I've shown you how to access the table. I've shown you how to change your steps on your table, okay, as we're going through that for your table set and everything else. And that information's right here. And second, table, arrow through the table, and I can get there and make those things happen. So be familiar how to work with your calculator in these situations so things can happen for you, okay? But I have also showed you how to do it algebraically, look at the picture graphically on your calculator. Now in the next one, we have a situation that I want you to put this stuff in L1, put that in L1, put this in L2. And how do you get there? So let's talk about that, because that's kind of a confusion. So now I'm going to go to a different table. So I'm going to be using my stat, but I want second stat. Oop, I lied, just hit stat once. Okay, you see edit, I want to edit a list. So I'm going to hit enter. And under list 1, if you have stuff there and it's not the same stuff, I've already, you hover over L1, you hit clear, and then you arrow down, and the whole list will go bye-bye. Okay, but since I already have that in there, enter 2002 to 2007 here on the table, and enter these in L2. If you need to, turn off the video to do so. Now, after that table's entered, I want you to we're going to talk about a few things, but the first thing we're going to do is I'm going to show you, this is the table we're going to be shooting for out of our calculator, roughly, okay? We're going to write a linear equation for Americans' income, Y, in terms of the year X, using the points 2002, that's 8.9, and 2003, 9.2. That's this first two. Now, if we do this, we will get an equation that comes through here that uses those 2 points, okay, as we get that going. It's not a linear regression because we're missing quite a few pieces of data on the linear regression. Remember, when we run a linear regression, it should look something like this to approximate the data all the way through and just notice our trend. But in this particular one, we are writing an equation based on 2 pieces of data in the first couple years. Okay, so I have to have slope. I have my points, my y over x, okay, and I find my slope, which is 0.3 trillion per year. So I'm increasing by 0.3 trillion a year. And let's talk about this. This is Americans' personal income in trillions of dollars, the total American personal incomes in trillions. Now, point slope form, I got a point. I don't care which one you pick one of them, it'll always work. And then a slope, and we got the slope. So I'm picking 2002, and I multiply this out, and then we've got y equals 0.3x minus 591.7. Well, let's look at this, what it looks like on my graph. So I'm going to deselect our previous graph equation, and I'm going to go up here, and I'm going to select it, enter. Now on this one, in order for us to set our window, I want to go to zoom because we're using stats and plot 1. I'm going to turn on, well, I'll show you how to get the plot 1 first. We're going to get the plot 1 here, okay? And I'm going to go second plot 1. Now we entered those things in L1 and L2. So I enter this. First of all, I want to turn this on. And I want to arrow down to my X list, because on my X list, I'm going to use L1 as my X values, time is my independent variable, and L2 as my Y values, my dependent variable. And I have magenta, and it's going to be squares that I'm going to graph. Okay, now I've got all that set in my graph. My next thing, I'm going to go to zoom. Zoom stat, and that's number 9. So I'm going to hit 9, and it'll graph my stuff. Not only am I graphing my data, but I'm graphing the line we just put in, that 0.3x minus 591.7. And notice it's exactly about where I thought it would be, at the beginning. It's not a best fit line, but we're going to answer some questions based on this. And again, because I'm answering questions, I want to make sure you recognize what questions we're answering as we go. So we're going to get to B here, and I'm going to pull up my calculator. Use the equation in A to estimate the Americans' income in 2005. Well, in 2005, I can do something here. Remember, my graph is Y1. This is kind of a cool little extra on your calculator. So hit second quit, and we're going to hit the vars, okay? And I'm going to go to Y vars. I'm going to arrow over 1, and I want function variables for y, and I want y1, or excuse me, y1. That's where we've got this. Now I'm going to put in this because we're going to go in 2005, and close it. That'll give me my answer, 9.8. Now I've got some people that are like, what? Remember, this is function notation. They took the y1 equation, put 2005 in for x, and gave me an answer. Now, let's check out. It does the same thing here, 9.8, and I got to know it's 9.8 trillion. So I've used my calculator to check it out, and I want to do the same thing on the next one. Now, I'm pretty much in the next question going to be recalling the same pieces of information. Okay, on my calculator, I can go to y1 again under vars, or I can hit second enter, and it recalls my last entry because I'm only going to change two numbers, 2010, and hit enter. Now I'm going to check, make sure algebraically, as I plug in 2010 and I come up with 11.3, it's the same answer. Isn't that a wonderful thing? It's a nice shortcut. Now, superimposing the graph, okay, I've superimposed the graph and I've shown you what that is. I've got my graph here, and I got my plot on because that's where it is, so I'm going to superimpose it in the same spot, and I hit graph, and we've seen that. But again, a list on how to get there is here with L1 in year, L2 is the amount. You go to stat plot, second y equals 0, and I can also look at my, I don't know why I have y equals 0 there. Go to stat plot, y equals 0. I wouldn't put y equals 0. I don't know why I put that in there. So we're going to get rid of that. Okay, maybe it won't let me get rid of that. Let's just get rid of that entirely. Go to stat plot, second. I want to check that. Go to stat plot. No, second. Stat plot. Enter. Yeah, I don't know why. Oh, it's just second y. I don't know why I wrote y equals 0. I think that I'm trying to get you the second and then y. That's stat plot. Okay, so I'm happy. I'm sorry about that. Every once in a while I'll write something and I'm thinking about something else. I apologize. Enter select plot on. Years are x-axis, independent variable, and the other is the y-axis. Okay, so as we're going here, let's see what else we've got. We got the chapter 1 opener problem, and this is going to be distance equals rate times time. Assume that the speed of light is approximately 186,000 miles per second. It took a long time to arrive at this number. See the note below about the speed of light. But if the distance from the moon to the earth is approximately 237,000 miles, find the length of time required for light to travel from the earth to the moon. Now remember, this is per second, so that's a rate. That's 186,000. This is a distance. So if I take my distance divided by rate, I get time because I want to know find the time. Okay, so I'm looking at here miles over miles per second equals miles times, miles per second. Boy, my answer should be in seconds, and this is, yep, that works. That all works. It should be in seconds. So as I'm looking through with my units, I've got my distance divided by my rate. This should be my time, and my time is 1.27 seconds. Okay, so it will take light 1.27 seconds to travel from Earth to the moon, and then it'll take something like 2.54 seconds to travel from the Earth to the moon and back. Now, if light travels from Earth to the sun in 8.32 minutes, approximate the distance from Earth to the sun. Now, here's the thing. I have 186,000 miles per second, so I got to find out how many seconds 8.32 minutes are. So in doing that, I'm going to find out that there are 499.2 seconds in 8.32 minutes. Okay, so now I got rate times time, distance equals rate times time, 186,000. I got 4. So now we're going to take distance equals rate times time. And keep in mind, our rate is 186,000 miles per second. Okay, so we need to take 5 hours and 29 minutes, get it to seconds. So 5 hours times 3,600 gives me how many seconds in 5 hours? And then plus 29 times 60 gives me the seconds in 29 minutes, and add them together. And so now I'm at a point. Oh, yeah. Now I'm at a point where I've got 186,000 come 19,740. And I'm going to find out that Pluto is, what is that? Million, trillion, 3,671,640,000 miles away, according to this calculation. Now in this next section, I want you to do a quick review on solving for X and Y. I'll walk through them afterwards, but you go ahead and get your solve on and get those done, and then check your work. Make sure, or check my work for that matter. So turn it off and give it a try for this review, and we'll get that going. In problem 1, I'm going to take 25 and subtract it from both sides, and then I divide by negative 75 and get negative 7/3. And 2, I'm going to subtract 400 and I get myself at 250, and then I divide by negative 50 and get x equal 5. And this next one I got to distribute 3, and then I distribute 4 to the separate parentheses that they're outside of. And I'm going to combine like terms and get 2x minus 17 equals 7, and then add 17 to both sides, and 2x equals 24, and x is 12. Distribute again and get 14x plus 2, 5 minus 15x. I combine like terms by adding 15x to both sides, so I get 29x plus 2 equals 5. Subtract 2, divide by 29 and get 3/29. Here I'm going to solve for y. That's kind of a big deal, getting us used to getting things ready to put into the calculator. So I'm going to subtract 2x and then divide by negative 5. After I get that subtraction, that's negative. And this should be, as I'm looking this over, this should be a negative here, right there. Okay, so that's negative 21. And this next one, in 6, we're looking at 13x and 14y. So now I'm going to subtract 13x as I go across. And then I'm going to multiply by 4 all the way through. So I got negative 4 and 8. And that's y equal negative 4/3 x plus 8. Distributing 2x and 7 and the 2, I should say, to x and negative 2y. And then after I do that distribution, I add my 2x over here, or subtract 2x. So those 2x's are gone, and I get negative 4y. And then I add 4y to the other side and divide by 5. Okay. Here, I'm going to get the x squared across, so x squared is going to be negative x squared plus 3x minus 2y, and as I'm going through, I think I made a mistake with something here. Let's just double check. Why do I have a 3? Oh, there's my 3y. I'm adding 2y here to get here, so now I got to divide by 3 and that's -3. All right, good. And lastly, just simplifying the fraction. This is 4. This is 6. That becomes 4 6, which is 2/3. This is -10. This is -12. We got -10 and 12. This is 5 6. So we're good to go. All right. Hopefully everything's going well. Our assignment's there. And folks, just make sure you're keeping on trucking. If you notice any issues with solutions, please let me know. I don't contend to be the most perfect calculator in the world, but I do fairly well for most things. I hope things are going well, and thanks for being in class. Have a great day.